This is a revision video for P5b, Scalars and Vectors and the Equations of Motion. This section of P5 has got quite a lot of maths in it, so you need to be comfortable with Pythagoras. For this triangle here, the equation is c squared equals b squared plus a squared. So to work out the length of c, you need to do the square of this side plus the square of this side, and then do the square root of that number. Or the length of the hypotenuse is equal to the square root of b squared plus a squared. In this topic you also need to be pretty good at trigonometry, and you need to be able to find out an angle if you are given either the hypotenuse, the opposite side, or the adjacent side. The sine of the angle is equal to opposite over the hypotenuse. Cos of the angle is equal to the adjacent side divided by the hypotenuse. And the tan of the angle is equal to opposite over adjacent. The most common one we use in these calculations in scalars and vectors is this one, although you do need to be comfortable in doing this one and this one as well. We're now going to talk about the difference between scalar and vector quantities. A scalar quantity is a quantity that has size only, or a magnitude only. Some examples are mass and speed. Temperature is another one. A vector quantity is one that has size and a direction. So an example of this could be force, velocity, and also acceleration. Vector quantities are quite important to us. For example, if a car is travelling at 50 km per hour, this tells us how fast the car is moving, but not what direction it's travelling in. This is the speed of the car, and it's only a scalar quantity. If we imagine a car that's travelling north at 50 km per hour, we know how fast the car's moving, and we know what direction it's moving in. This is a much more useful quantity for us to have. Okay, so what I would like you to do is pause the video and then have a look at these quantities. Which of them are scalars and which of them are vectors? Okay, the first one, 2 meters a second. This is speed, so it's a scalar quantity. 30 kilograms. This is a mass. It's also a scalar quantity. 40 newtons to the right. This is a force and a direction, so it is a vector. The time, 12:30, is a scalar quantity. And the last one is a velocity because it has speed and a direction, so that is a vector. Vectors are also important when we've got things that are moving in opposite directions. Sometimes things appear to be moving faster or slower than they actually are, depending on which direction they are moving to you. This is called relative speed. Now imagine that you're a passenger in the red car. The red car is moving at 80 km per hour. And imagine that a green car comes to overtake you, and it's moving at 90 km per hour. The difference between those velocities is 10 km per hour. So to you in the red car, it will seem like the green car is moving at only 10 km per hour relative to you. If we think about cars moving in the opposite direction, now consider the blue car. The red car is travelling in this direction, still at 80 km an hour. The blue car is travelling in this direction at 20 km per hour. If the two cars are moving towards each other, then to you in the red car, it would seem like the blue car is moving faster than 20 km per hour. It would actually appear to you that the blue car was moving at 100 km per hour, which would be the addition of the two velocities. Whereas if you consider the cars moving in the same direction, we did the difference between the two velocities, or we took away this one from this one. So if you are moving in the same direction as something else, then you need to find the difference between them, and that will give you relative speed. If you are moving in opposite directions, then you will need to add the speeds to find the relative speed. This means that if two cars are heading in the same direction, then their relative speeds are lower, and if the two cars are moving in opposite directions, then their relative speeds are higher. Okay, what I'd like you to do now is stop the video and see if you can work out the relative speed in this question. Okay, so Susie is driving in her car at 30 kilometers per hour, and the car comes to pass her at 45 kilometers per hour. The relative speed, because they are moving in the same direction, will be 45 minus 30, which is 15 kilometers per hour. Now we're going to start talking about vector sums. These are a little bit different from relative speed, but they do, however, still depend on the direction in which the object is moving. So for this vector, we've got a man walking on a walkway. His speed is 1.7 meters per second, and he's moving in that direction. And the walkway is at 1.25 meters per second, also moving in that direction. Now, because the vectors are going in the same direction, if we want to work out this man's total velocity, then we can add them together. So his velocity would be 1.75 plus 1.25, which gives us 3 meters per second. Not forgetting that we need to include our direction, so it's 3 meters per second to the right. We can also use vector sums to work out the resultant force acting on an object. In this example, we have got 15 newtons that are pushing downwards, and we've got 38 newtons that are pushing upwards. Now, the vectors are still parallel, so we can add them together. However, they are in opposite directions. So one of these forces is going to have to be in the negative direction. So if we take our 38 newtons direction as positive, and this one must be in the negative direction. So then we have 38 newtons plus our negative 15, which will actually equal this, as a plus and a minus gives us a negative. So in this example, the resultant force is actually the difference between the two vectors, so 23 newtons going in the upwards direction. So you have to be careful here that when you're doing resultant vectors or vector sums, that you choose one direction as your positive direction and one direction as your negative direction, and that will help you to do your calculation easy. Okay, so I want you to stop the diagram, and I would like you to calculate the vector sums for each of these. Okay, so in the first diagram, if we take this way as our positive direction and this way as our negative direction, then we can see that we actually have to do 12, take away 5, which gives us 7 newtons. For the second diagram, because this is a vector sum, we've got 8 meters per second in the positive direction and 5 meters per second in the negative direction, which gives us a vector sum of 3 meters per second in this direction. In our last diagram, if we've got 30 newtons is pushing this way, we can take that as our positive direction, 25 pushing this way, and that could be our negative direction. Then if we do 30 minus 25, this equals 5 newtons in that direction. In the previous example, the vectors were parallel to each other, but there are some situations where the vectors are at right angles to each other. The resultant vector is this one here, or the one that represents the motion that's caused by the two vectors. This is where Pythagoras and trigonometry from the beginning are useful. if we want to find the value for this resultant vector, then we need to use Pythagoras. And if we want to find the angle or the direction of this vector, then we need to use trigonometry. So you can do it by calculation, or you can also do it by drawing a scale diagram and measuring the length of that side and the length of that side. And then if you measure the length of that side, it will give you the resultant. And you can also use a protractor to measure the angle. This is an example of a calculation where you have two vector quantities, but they are at right angles to each other. Imagine we've got a microlight that's flying with a velocity of 40 meters per second to the east. And then there's a crosswind with a velocity of 10 meters per second that's going north. Now that wind is going to have an effect on the microlight's flight. It's going to make it move towards this direction. And we can find out that resultant velocity from either drawing a scale diagram or doing Pythagoras and trigonometry. If you wanted to do a scale diagram, then you would have to set a centimetre to a certain number of meters per second. Then you would measure how long the length is in centimetres, and then how long this one is in centimetres, and using your scale you would be able to work out that the resultant velocity is 41 meters per second. You could then get your protractor, set it onto here, and find out that the angle is 14 degrees. So the microlight's trajectory then becomes 14 degrees north of east. Now you can also work this out mathematically using Pythagoras. So say we don't know what the resultant velocity is, and I set this to the letter R for resultant. We know from Pythagoras that R squared will be equal to the square of this side, which we will call M for microlight, plus the square of this side, which we'll call C for crosswind. So the length of the hypotenuse is the square root of the squares of each side. So we have here R squared equals M squared. So M is 40, so we need to do 40 squared, plus C squared. C is 10, so we need to do 10 squared. 40 squared is equal to 1,600, and 10 squared is equal to 100. So that means that R squared is 1,700. That means that to find out R, we need to do the square root of 1,700. This gives us 41.23 as our value for R, our resultant velocity. So we can round that down to 41 meters per second. Now, in order to work out the direction of flight for the microlight, we need to do trigonometry. So remember, SOHCAHTOA. Now we have the adjacent side and we have the opposite side. So the best one for us to use here will be this one. So tan theta equals opposite over adjacent. Tan theta equals 10 divided by 40. So tan theta equals 0.25. Then if you use your calculator to work out what theta is, you get an angle of 14.04 degrees. Okay, so I'd like you to stop the video now and have a go at working through some of these graded questions. Okay, so now we're going to move on to the section about equations of motion. Here are the 4 equations of motion that you need to be familiar with. The first one, S equals half times U plus V times T. The second one, v equals u plus at. The third one, v squared equals u squared plus 2as. And then the fourth one, s equals ut plus half at squared. Okay, so before we use them, let's just have a run through and make sure we know what all the symbols mean. S is the displacement. Obviously, that's measured in meters. U is the initial velocity in meters per second. V is the final velocity. A is acceleration, which is measured in meters per second squared, and T is the time. So we'll try and remember what each of the symbols mean. Okay, so the best way to do these equations is to practice them. The first one, an example. A car sets off from rest to a velocity of 12 meters a second. This takes 3 seconds. Calculate the distance travelled, s, in meters. The best way to approach these questions is to write down firstly what you know. Then when you've got what you know, you can choose which equation you want to use. So this one, the car sets off from rest. So it's starting at rest. So u, its initial velocity, is 0 meters per second. Then it says it reaches a velocity of 12 meters per second. So v is its final velocity. It says this takes it 3 seconds. Then we don't have any more information apart from that the question wants us to work out distance. So S is the question mark. So you have U, V, T and S. If you look through your equations, you'll find out that the best one to use is S equals a half U plus V times T. Then all you have to do is put your numbers in. So we've got half, U is 0, T is 12, V is 12, sorry, and T is 3. So that means that we actually have 6 times 3, which gives us S as 18 meters. Okay, now what I would like you to do is have a look at the second example. Remember to write down what you know and then choose the appropriate equation to use. Okay, so for this one, you should have got an answer of 22 meters. And you should have found that the best equation to use again would have been this one. Okay, so some questions that go through using different equations. Here we've got an aeroplane that accelerates to a final velocity of 200 meters per second. So I know that V is 200 meters per second. And it takes it 20 seconds. So T is 20 seconds. And the acceleration is constant at 4 meters per second squared. So acceleration is 4. What is the initial velocity of the plane? What is u? So with this question, the best one to use is V equals u plus at. We start putting our numbers in here. We've got V, which is 200, equals u, which is our unknown, plus a, which is 4, times t, which is 20. Now remember that you need to do that bit first because it's a times t. So that becomes 200 equals u plus 80. Then if we do a bit of rearranging, we can see that 200 minus 80 equals u, and that gives us an initial velocity of the plane of 120 meters per second. Okay, so time for another example. Remember first, write down what you know. Acceleration is 3 meters per second squared. We have a starting speed or starting velocity, u, is 1 meters per second. we have a time of 3 seconds, and we have a final velocity v of question mark. So again, the best equation to use for this one will be v equals u plus at. Okay, v is our question mark, u is 1, plus the acceleration, which is 3, times the time, which is 3. So that gives us 9, plus the 1, which is 10 meters per second as a final velocity for the boat. In this example, we've got a car that brakes on a road with an acceleration of minus 3 meters per second squared. Now remember that acceleration with a negative value means that the car is deceleration. It says it comes to a stop after 5 seconds. What was its initial velocity? So again, we are starting by writing down what we know. That acceleration is minus 3 meters per second squared. The time is 5 seconds. Now at this point, you might think the initial velocity is what we need, so that's a question mark. However, where do I go now? What is the final velocity? This is where you have to be very careful reading the questions. It says the car comes to a stop. So its final velocity is going to be 0. It is at rest, it's come to a stop. Again, the best equation to use here is v equals u plus at. v is 0, u is what we want to find out. Then we've got our acceleration, which is minus 3, times the time, which is 5. So it says 0 equals u minus 15. Okay, because a plus and a minus together are a minus. So if we add 15 to each side, see that 15 equals u. So the initial velocity is 15 meters per second. Okay, so here are some questions for you to try. Remember that you need to write down everything you know first. Don't try and choose an equation before you've done that. The best way to make sure you've got the right equation is to write down everything you know. Okay, so stop the video now and see if you can have a go at working out the quantities that are needed. Okay, so with the first question, you should have decided that the best equation for you to use would be s equals ut plus half at squared. Remembering that it's just the t bit that you are squaring. You should have found out that the distance equals 88 meters. And with the second question, you should have found that the best equation to use is v squared equals u squared plus 2as. And you should have found that the velocity, the final velocity, 28.3 meters per second. Okay, and that completes this section about scalars and vectors and the equations of motion. What you need to do now is making sure that you have a list of your 4 equations. You need to start working through these graded questions.